channel. So this video we will be starting a new chapter 6 from the textbook, which is triangles. So here we will be discussing about how to prove the similarity between the triangles, also the basic proportionality theorem and the converse basic proportionality theorem. First we will explain the chapter and then we will do the textbook exercises. If you are new to the channel, please don't forget to subscribe. So let's start. So what are congruent figures? So we have learned this in our previous classes. In two congruent figures, both the corresponding angles and the lengths of the corresponding sides are equal to each other. So we say two figures are congruent when their corresponding angles and the corresponding sides are equal to each other. So it needs to be the size and shape should be equal to each other. So if we can say all circles with the same radius are congruent, all squares with the same side lengths are congruent, and all triangles with the same side lengths are congruent. So here let's see these figures down. These two triangles, we can say these are congruent because all the corresponding angles and all the corresponding sides are equal. Similarly, these two squares, the corresponding angles are equal and corresponding sides are also equal. So these are equal in size and similar in shape. So those type of figures are called congruent figures. And for circles, if we take circles, any circles with the same radius are congruent. So congruent figures are figures which have equal, all the corresponding angles are equal and the length of the corresponding sides are also equal. Now let's see some different types of pictures. So let's look into below pictures. So here we can see the picture of Taj Mahal. We can see the first picture, the second and third. So are these similar? Yes, these are similar pictures. But can we say these are congruent? No, because the size of these pictures are different. So the first picture is bigger than the second one, and the third picture is smaller than the second. So all the size of this picture are different, but these are similar. So those shapes are called similar figures. So similarly, look these squares. We have the first square, the second and third. And the triangles, we have a bigger triangle, then another size triangle and a smaller size triangle. So we can say two polygons of the same number of sides are similar when their corresponding angles are equal and their corresponding sides are in the same ratio. So how we can say two polygons or two figures, like polygons are similar? So that needs to be like the corresponding angles needs to be equal. Let's see the picture here of the Taj Mahal. We can see the corresponding angle. So this angle here of the bigger picture, first picture, and this is the corresponding angle for the same, and this is the corresponding angle. So all these angles are equal. So for two figures to be similar, the corresponding angles needs to be equal. If we take the other corresponding angle of this side, it will be here. We can say all these are similar. Similarly, in this square, we can say all the corresponding angles are equal. All the corresponding angles are equal. This angle also equal to this here. All are right angle. This corresponding angles are also equal here. This corresponding angle of this is also equal. So we can say all the corresponding angles of these squares are equal. Let's assume the sides of the first square is like 4 cm. So you know all the sides of the squares are always equal. So 4 cm and 4 cm. And for the second square, let's assume it has 3 here, 3 cm, 3 cm and 3 cm. And the last one has 2 cm, 2 cm, 2 cm and 2 cm. So we can see all the sides are, the corresponding sides are in same ratio here. So if the first side, let's name this square as A, B, C, D, and let's name this as P, Q, R, S. So if we take the first side here, which is AD, is equals to 4 cm, and PS is 3 centimeter here. So and if we take AB here 4 and the corresponding side is 3. So it is in the same proportion. Like if we take the corresponding proportion for the corresponding sides, it is same for all the sides. So we can say all the squares are always similar. Even though size is different, because their angles are, the corresponding angles are always right angle. So all the squares are always similar. Let's look into the 3 different triangle here, 3 different size triangle. The first triangle we can say this as, let's assume this as an equilateral triangle. So for an equilateral triangle, always their angles will be equal, right? It will be 60 degree. This will be also 60 degree and this will also be 60 degree. So let's assume this all are 60 degree. Similarly, even if the side is not the same size, but their angles are all equal. The corresponding angles of this triangle is also equal. So we can say all the equilateral triangle are always similar, because equilateral triangle have same angles. All the angles of an equilateral triangle are same degree. Like always it will be 60 degree. So this is 60 degree, 60 degree and 60 degree. But if we look into the length of the sides, they will be also in a proportion. So that's 2 polygons of the same number of sides are similar if their corresponding angles are equal and their corresponding sides are in the same ratio. Let's look into 2 different quadrilateral. So we have a quadrilateral ABCD and PQRS. So we can see, let's look into the angles first. So corresponding angle of A, here it is 105, which is the corresponding to A is here angle P, which is also 105, correct? And angle B, which is 100 degree, and the corresponding angle for angle B is angle Q, which is also 100 degree. Angle C, which is 70 degree, the corresponding angle for C is angle R, which is also 70 degree. Same, the angle D, which is 85 degree, its corresponding angle for angle D is angle S, which is also 85 degree. So we have seen, proved that we know that all the corresponding angles are equal in measure. Now let's look into the sides. So the first side, the AB is 1.5 centimeter and the corresponding side to AB, which is equals to, let's write it here, AB by PQ, right? PQ is the corresponding side of AB for in the second quadrilateral, which is equals to 1.5 divided by 3, correct? Which is equals to 1 by 2. Let's take the second side, which is BC. BC divided by, which will be the corresponding side for BC is QR, correct? So that is BC equals to how much? 2.5 and QR equals to 5. Again this is equals to 1 by 2, correct? Let's take the third side, which is CD, and the corresponding side for CDR is RS. So that is CD is equals to 2.4 and RS equals to 4.8, which is also equals to 1 by 2. The last side is DA. The corresponding side for DA is SP, which is equals to 2.1 divided by 4.2, which is also 1 by 2. So now we can see all the sides are in proportion, are in same ratio. Hence these two quadrilateral are similar, we can say, because all the corresponding angles are equal and all the corresponding sides are in proportion or in equal ratio. So we can say these two quadrilaterals are similar. Let's see another pictures, which is one is here one square and another square. So for squares we know all the angles are 90 degree, all are right angled. So all the corresponding angles are equal. We can say all the angles here are 90 degree. So the corresponding angles are equal for this both of the square. Now let's look into the sides. If we take the first side, which is AB by the corresponding side of AB is PQ here, and AB is equal to 3 and PQ is equal to 3 by 3.5, correct? Let's look into the next side, which is BC, and the corresponding side for BC is here QR. BC given 3 centimeter and QR is given 3 centimeter. So now it is clear that these are not in the same proportion. Hence these two are not similar. Hence these two pictures are not similar, because the sides are not in the corresponding sides are not in the proportion. Similarly, let's see this figure. We can see all the angles of this square is 90. Hence it is a square. All the angles are 90 degree, right? All the angles are 90 degree, 90 degree and 90 degree. And the sides are given 2.1 centimeter. Let's look into this figure. Let's look into the corresponding angles. Is that in 90 degree? No. We can say these are not 90 degree. So these also not similar. These two figures are also not similar to each other. So these are the rules for how to see whether two polygons are similar. So either the corresponding angles needs to be equal and the corresponding sides needs to be in same proportion. So let's do exercise number 6.1. It has only few questions and it is very simple. So let's solve those questions now. The first question is fill in the blanks using the correct word given in the bracket. So we have first question is all circles are dash. So in bracket we have given the options congruent and similar. So for all circles we can say all circles are not congruent. Only if the radius of the circle are same, that's the time where the two circles are equal or congruent. If the radius are equal, then the circles are congruent. Otherwise we can say it is similar. So all circles are similar. So this is the correct answer. Why? Because only the circles will be congruent if the radius is same. For figures needs to be congruent, the size and shape should also be equal. So second question, all squares are what we can say similar or congruent? Again it is similar. All squares are always similar, because if we take a square, we can say all the angles will be always equal. If we take two squares, all the angles will be always 90 degree, all will be 90 degrees. So all the corresponding angles are always equal. So all the squares, and if we take the squares, the sides will be in proportion to each other, because squares have equal sides. All the squares have equal sides. So we can say all squares are similar. But like all the squares is not having equal sides, but each square have all four sides are equal in one square. So if we take a bigger square and a smaller square, it will be in same proportion. So the sides are in proportion and the corresponding angles are equal. Hence we can say all squares are similar, but it is not congruent. Third one, all triangles are similar. Which type of triangles? We can say what is isosceles? Isosceles triangle are triangle with only two sides are equal. So we can say all equilateral triangle are similar. Equilateral triangle are triangles having all the three sides are equal and all the three angles are equal. So all equilateral triangles are similar. So this answer will be equilateral. All equilateral triangles are similar. Fourth question, two polygons of the same number of sides are similar if the first criteria for two polygons to be similar, the first criteria is their corresponding angles needs to be equal. Correct? The corresponding angles needs to be equal, and B, their corresponding sides are in proportional. The corresponding sides should be in proportional. Okay, so here it will be equal and the second blank will be proportional. So two polygons of the same number of sides are similar when the first criteria is their corresponding angles needs to be equal, and the second criteria is the corresponding sides should be in proportion. So next question is give two different examples of pair of similar figures and non-similar figures. For similar figures we can write similar figures. It can be a pair of equilateral triangle, right? A pair of equilateral triangle will be always similar, and next can be a pair of square, which is also will be all squares are always similar. So all equilateral triangles are similar, and all squares are also similar. Now let's see what is non-similar figures. Non-similar figures. We need to give a pair of non-similar figures. So the first one can be a triangle and a rectangle. Let's see, a triangle and rectangle are two different shapes and two different sizes. So they will be always non-similar. This will be always non-similar. And another pair can be a square and a rhombus or trapezium. Let's say trapezium. A square and a trapezium will be always non-similar, right? Will be always non-similar. So if we ask for two different examples of pair of similar figures, we can write a pair of equilateral triangle will be always similar, and a pair of squares will be always similar. For non-similar figures, we can say a triangle and a rectangle will be always non-similar, because it's both are two different shapes, and a square and a trapezium, which is also two different shapes, will be always non-similar. Let's see the last question from this exercise, which is state whether the following quadrilaterals are similar or not. So as per the similarity rules, we need to, two polygons are considered as similar when their corresponding angles are equal and their corresponding sides needs to be in proportion. So let's see the corresponding angles here for this rhombus PQRS. Angle P is corresponding to angle A. So here we can say this is 90 degree. So this is 90 degree, and this is, because it is a rhombus, this is less than 90 degree. So the first criteria, that the corresponding angles are equal, are not satisfied. Even if we see the sides are 1.5 centimeter and here it is 3 centimeter. So the sides are in proportion, but the first criteria, which is the corresponding angles to be in equal, that criteria is not satisfied. So hence we can say these two we can write as the corresponding angles are not equal. These quadrilaterals are not similar. So because the corresponding angles are not equal, these two quadrilaterals are not similar. So let's continue the chapter explanation. Now let's see the basic proportionality theory, so which is called as BPT. Let's see the definition first. So definition of basic proportionality theory is: if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. Let's see this. This is the definition of basic proportionality theory, which we call as BPT. So if a line is drawn parallel to one side of a triangle, so we can see in the below picture the triangle. Let's consider this as ABC. Triangle ABC. We have drawn a line which is parallel to one side of the triangle. So this line is parallel to BC. We have drawn a line which is DE. Let's name it as DE, and it is parallel to BC, right? In that case, the basic proportionality theory says the other two sides are divided in the same ratio. So if we draw a parallel line to one side of a triangle intersecting the other two sides at distinct points, the other two sides are divided in the same ratio. So this says that if BC is parallel to DE, correct? This is given. BC is parallel to DE, and it says that, as per theory, it says that AD by DB is equals to AE by EC. That these two sides are divided in the same ratio. Now let's see how we can prove this. We need to prove this by drawing some more lines on this figure. Let's see how we can prove that. So let's construct few more lines on this figure. Let's construct few more lines on the same figure. So let's draw a perpendicular from point D to AE. Let's draw a perpendicular from point D to AE, and let's name it as N. That point as N. Okay. Similarly, N. Similarly, let's draw another perpendicular from point A, from AD, perpendicular to AD from point E. Point E. And just let's name that point as M. And we can say these are perpendicular. So this is perpendicular. This is also perpendicular. Okay. Right. Also, let's join B, E, and let's join DC. DC. So what we have done? We have drawn a perpendicular. Draw a perpendicular to AD from perpendicular to AD from E, and a perpendicular from the second perpendicular was from AE from D. Correct? Also we joined DC and BE. So now we have changed this, we have added two more lines to the given triangle. Now let's do that in a fresh page. So here we can just name this triangle as A, B, C, right? And we have drawn a parallel line which is DE, and drawn a perpendicular to AD from E which is M, and a perpendicular from D to AE which is N, and also we have joined DC and EB. Correct? Now, and we have given DE is parallel to BC. This is given, right? Given, and we need to prove AD by DB is equal to AE by EC. Correct? So for this, let's consider the area of few triangles which we can see in this figure. So first let's take the triangle. So area of the triangle we can write it as AR, and then the triangle name. So area of the triangle A, D and E. Let's take the area of a triangle ADE. So which is area of triangle ADE. So what is the formula to find the area of the triangle? Half into 1 by 2 into base into height. Correct? 1 by 2 into base into height. So which is equals to 1 by 2 multiplied by, which is the base here, ADE. So base is equals to AD and height is EM. Height is EM. So for if you look into this triangle ADE, the height is EM. So this is our first equation. Similarly, let's see the area for triangle DBE, which is a triangle DBE, D, B and E. Let's see that area for triangle DBE, which is also equals to half into base into height. Correct? Which is half into DB. The base is DB and height will be height equals to EM. Why it is EM here? So we know triangle DBE is an obtuse triangle. So for any obtuse triangle, we have learned this in the lower classes, previous classes. So if for, let's draw that here, for any obtuse triangle. So this is an obtuse triangle. If we need to consider to see the height of this obtuse triangle, we always calculate that by extending these lines to here and drawing a perpendicular to this line, right? So this will be the height for the obtuse triangle here. So similarly we can say this is the perpendicular from one of the point which is E from the obtuse angles, and this will be then the height for this obtuse triangle, which is the triangle DB will be EM. We have learned this in our lower classes. So this is our second equation. So now let's consider the area for triangle AED, which is the same as the equation 1 ADE. I have taken ADE, instead of that I have taken AED. Same, that will be half into base into height, which is equals to 1/2 into half times AE. AE will be the base times DN, correct? The height of, if we take AED, the height will be DN, which is our third equation. Now let's see the last one. Let's take the triangle which is ECD, similar to DBE. Similar to this triangle, let's take the triangle on the other side, which is ECD. ECD. So that is area of triangle ECD will be equals to half into base into height, which is half into 1/2 into base is here EC and height again, because it is an obtuse triangle, we need to take the height as EM. No, so that will be height as DN. And this is the fourth equation. Now we have got 4 equations from this from the given triangles. Now let's solve that each other. Let's write that in a fresh page. So that is area of triangle ADE equals to half into, let's turn, area of triangle ADE equals to half into AD into EM, which is equation number 1. Area of triangle DBE equals to 1/2 into DB into EM, which is equation number 2. Then third one, area of triangle AED equals to 1/2 into AE multiplied by DN, which is equation number 3. Now the last one, area of triangle ECD equals to 1/2 multiplied by EC multiplied by DN, which is equation number 4. Now let's divide equation number 1 and 2 and equation number 3 and 4. So let's divide equation 1 divided by 2 and 3 divided by 4. So for that, area of triangle ADE divided by area of triangle DBE, correct, is equals to 1/2 multiplied by AD multiplied by EM divided by 1/2 multiplied by DB multiplied by EM. So this is equation 2 divided by equation 1 divided by equation 2, which is equals to AD divided by DB. How? We can cancel 1/2 EM and EM. So the left is only AD by DB. Similarly, let's divide equation 3 divided by 4. So that will be area of triangle AED divided by area of triangle ECD is equal to 1/2 multiplied by AE multiplied by DN divided by 1/2 multiplied by EC multiplied by DN, which is equals to AE divided by EC. How? We can cancel 1/2 and DN. So now we have arrived as AD divide area of triangle AD divided by area of triangle DB is equal to AD by DB. and area of triangle AED divided by area of triangle ECD equals to AE by AEC. Let's write that here. Area of triangle ADE divided by area of triangle DBE is equals to AD by DB, correct? And then other one was area of triangle AED divided by area of triangle ECD is equals to AE divided by EC. Let's look into this together. See, here we can see the numerator of the first left hand side are same. Area of triangle ADE and area of triangle EED are same. So we can, the numerator is already equal. So that is, now we just need to prove the denominator. Like if these denominators are equal, like let's see area of DBE and area of ECD. Let's see that triangles in the figure. Let's draw that here. Oh no, let's look into in the figure. Triangle DB and triangle ECD. So triangle DBE and ECD. So we have learned in our previous classes like two triangles on same base. So the base is here same. The two triangles on same base between the parallel lines. So the, and this is also given. BC is parallel to D, which is given in the question. So if two triangles with the same base formed by in between the parallel lines, the area will be always equal. So area of the two triangles on same base between the parallel lines are always equal. So we can say area of DBE is equals to area of ECD. How? Like area of, this is proved by area of two triangles on same base between the parallel lines are equal. So we have proved that the denominator are also equal, like area of triangle DBE is also equal to area of triangle ECD. So now we can write as area of ADE. Let's write that here. Refresh. So that is area of ADE, triangle ADE divided by area of triangle DBE, correct, is equals to area of triangle, what we have already proved that area of triangle AED, which is also AED, we can write it as ADE or AED, both are same, correct. Let's write clearly, which is area of triangle AED. ADE and AED both are same. Because both are same triangles, so hence the area will be also equal. So an area of DBE and area of ECD. This also we proved by area of this theorem, which is area of two triangles on same base between the parallel lines are equal. So let's see that this will be, if we know two parallel lines here and if a triangles are joined here with the same base, these two triangles will be always equals. These two triangles with the same base will be always equal. Now which is equals to AD by DB, which is equals to AE by EC. This is what we have to prove. Now we have proved that AD by DB is equals to AE by EC. AE by EC, which is what we have to prove as per the base. basic proportionality theory. So what does it says? It says if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. So we have given that BC is parallel to DE. DE is a line drawn parallel to BC, and in that case the two sides which this parallel line intersects divides the two sides in the same ratio. So which is AD by DB should be equal to AE by EC. So we proved that through basic proportionality theorem. Now let's see the reverse of this basic proportionality theory. So the converse of this basic proportionality theory. As the name says, it is the reverse of basic proportionality theory. So let's see the definition first. If a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. So what we have given in BPT, like the basic proportionality theory says that if we draw a parallel line to one of the side of the triangle with the parallel line with two distinct points on the other two sides, the two other sides are divided in equal ratio. But here the converse of basic proportionality theory says that if a line divides any two sides of the triangle in the same ratio, then the line is parallel to the third side. So let's see. So this is the definition of converse of basic proportionality theory. So let's consider this triangle A, B, C, and we have drawn a line DE which intersects AB and AC at two distinct points. So we need to prove that DE is parallel. And what we have given is if a line divides any two sides of triangle in the same ratio. So already the two sides are in same ratio. So we can write AD by DB is equal to AE by EC. This is given. And we need to prove that DE is parallel to BC. This has to be proved. Okay. So we have already given AD by DB is equals to AE by EC. So now let's assume that DE is not parallel. Let's consider that DE is not parallel to BC. So we are considering that DE is not parallel to BC, and let's consider another point E dash. Let's assume E dash and join D to E dash, and let's assume that DE dash is parallel. So let's assume DE dash is parallel to BC. DE dash is parallel to BC. Now from BPT, so now let's see how we can prove that. So we have given AD by DB is equals to AE equal to AC. Let's write that here. AD by DB is equals to AE by EC. This is given. And we have considered what? We have considered DE dash as parallel to BC, right? So if that is in that case, we can write AD by DB will be equals to AE dash by E dash C. This is as per BPT. Now we have learned that as per the basic proportionality theory, if a parallel line is drawn to one side of the triangle, the other two sides will be divided in equal ratio. So from the basic proportionality theory we can say, and we have considered as DE dash as parallel to BC. So then we can say AD by DB is equals to AE dash by E dash C. Let's see. Now we can see both the left hand side are same. AD and this are same, and let's see this and this is same. AD and DB is same. So if LHS is same, then RHS, the right hand side, let's write that clearly. If LHS is same, then the right hand side will be also same. So we can say the right hand side is AE by EC is equals to AE dash divided by E dash C. Correct? Because the left hand side was already equal. So in that case we can say the right hand side will be always equal. So now let's add 1 to both the sides. So let's add 1 to both the sides. So that will be, let's add 1 to both sides. So that will be AE by EC plus 1 equals to AE dash by E dash C plus 1. Correct? So that will be, if we take the LCM will be EC. So that will be AE plus EC divided by EC. Correct? Will be equals to AE dash plus E dash C will be divided by E dash C. Correct? Now AE plus EC. What is AE plus EC? Let's look into the figure. AE plus EC is AC, right? So we can write as AE plus AC is equals to AC. AC divided by EC is equals to AE dash plus E dash C. Again, AE dash plus E dash C is also AC. So that is also AC by E dash C. Correct? Now hence EC, now we can say AC is equals to EC and AC is equals to E dash C. So if the numerator are same, we can write it as, let's write that here. If AC divided by EC divided by EC is equals to AC divided by E dash C. Correct? If the numerator are same, then the denominator will be always same. So we can say hence EC equals to E dash C. EC equals to E dash C. If that is the case, if EC is equals to E dash C, how it will be possible? It will be only possible if E overlaps E dash. So that is if E coincide. Otherwise we can say coincide E dash. So that's the only time where E will be equal to EZ. So it is overlapping. So this means E dash is overlapping or coinciding E. So this proves that. So this proves that our assumption DE dash to what we assume? We assume DE dash is parallel to BC is correct, right? Is correct. We have assumed that DE dash is parallel to BC. So from here we can say we find that C is equals to E dash C and E is coinciding E dash. So here because E dash and E are coinciding, we can say DE is parallel to BC because E is coinciding E dash. So which proves that our assumption DE slash parallel to BC is correct, which means that DE is parallel to BC because E coincides E dash. So this is how, like what does the basic proportionality, the reverse converse basic proportionality theorem says, if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. So now we have proved that the line is parallel to the third side. Now let's see the similarity of triangles. Similarity of triangles. How can we consider two triangles are similar? So now I have already mentioned that in the beginning of this video. Two triangles are similar if their corresponding angles are equal and their corresponding sides are in the same ratio. So we have seen initially we have seen like two figures, any two polygons are similar when their corresponding angles are equal and their corresponding sides are in the same ratio. So similar for triangles. How we can say two triangles are similar? the two triangles are similar if their corresponding angles are equal and their corresponding sides are in the same ratio. So let's see below two triangles, which is A, B and C, correct? And this triangle we can name as X, Y and Z. So in the given figure, two triangles, triangle ABC and triangle XYZ, are similar only when the corresponding angles, which is the corresponding angle of A, is X. So A should be equals to angle X. Angle B, the corresponding angle B is here angle Y. Angle B to be equals to angle Y, and angle C, the corresponding angle of angle C is angle Z. So the first criteria is their corresponding angles needs to be equal. So here angle A should be equals to X, angle B should be equals to Y, and angle C should be equals to Z. So these are the first criteria, and the second criteria is their corresponding sides are in the same ratio. So if we take the corresponding sides, the corresponding side of AB is XY, the corresponding side of BC is YZ, and the corresponding side of AC is XZ. So AB by XY equals to BC by YZ equals to AC by XZ. So then only we can say like the corresponding angles also to be equal and the corresponding sides should be in the same proportion. So these are the two criteria for the two triangles to be similar. Now there are three different criteria for similarity of triangles. So we already find that two triangles are similar when the two triangles, their corresponding angles are equal and their corresponding sides are in the same ratio. So now let's see the criteria for similarity of triangles. So there are mainly three criteria. The first one is angle, 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 or angle, angle. So in previous class we have learned the congruency of triangles, where we know that angle it's angle, 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 side, 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 and side, angle, side. So similarly, to prove the similarity of the triangle, we can use the same similarity. The first one is angle, angle, angle. So let's see how we can prove that. The first similarity criterion, which is angle, angle, angle. If in two triangles, let's see the below two triangles A, B, C and X, Y, Z. If in two triangles corresponding angles are equal, then their corresponding sides are in the same ratio, and hence the two triangles are similar. So what it is saying, the angle, angle theory is telling that if two triangles where the corresponding angles are equal, then their corresponding sides are in the same proportion. Hence the two triangles will be similar. Let's see if the corresponding angle of A here is X and B here is Y and C here is Z. Right? So that is B is 2 times. Let's write for C. So if it is saying that the corresponding angles are equal, then the corresponding sides are in the same proportion, hence the two triangles. So if this is the case, if all the corresponding angles are equal, then automatically the corresponding sides will be always in the same proportion. So this will be the corresponding side of AB will be in proportion to XY, and BC will be in proportion to YZ, and AC will be in proportion to XZ. So this is the first criterion for to prove two triangles to be similar, which is angle, angle, angle. Now let's see the second criteria, which is angle and angle. So we just mentioned angle, angle, angle. Similarly, that two angles are equal, still we can say the two triangles are similar. How? Because we know in a triangle, let's draw a triangle. If two angles are equal, then the third angle will be also equal, because the total of the angles of a triangle is always 180 degree, right? If these two angles are equal, then the third angle will be always equal because it sums to 180 degree only. So hence we can say angle, angle, angle or angle, angle are both the same. So even if only these two angles are given and mentioned that these two are equal, we can assume that these will be always equal, right? So hence by using the sum of this all the angles of a triangle is equal to 180 degree, we can say if two angles are equal, if two angles are equal, then third angle will be also equal. Now we can say we can use the angle, angle, angle theorem because all the three angles are equal for that triangle. So this is same to angle, angle theorem. We can say angle, even two angles are equal, we can say that two triangles will be similar. Now let's see the second criteria, which is side, side, side. So for side, 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 if in two triangles, sides of one triangle are proportional, that is in the same ratio of the sides of the other triangle, then their corresponding angles are equal. Hence the two triangles are similar. So in angle, 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 we mentioned that if the angles are equal, then the sides will be in the same ratio. But here we are given the if the sides of the two triangles are in proportion or in ratio, their angles will be always equal. So let's see, if this side, this triangle A, B, C and X, Y, Z. So if AB by XY is equals to AB by XY is equals to BC by YZ, which is BC by YZ is equals to AC by XZ. So that is equals to AC by XZ. So means all the corresponding sides are in same proportion, then the angles are equal. And the corresponding angles are also equal. A is equal to X, angle A equals to angle X, angle B equals to angle Y, angle C will be equals to angle Z. So the side, side, side theorem says if in two triangles, sides of one triangle are proportional or that is in the same ratio of the sides of the other triangle. If the sides are in proportion to, the corresponding sides are in proportion to each other, then their corresponding angles will be equal. So this is just reverse of the angle, angle, angle theorem. In angle, 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 we said that if the angles are equal, then the sides will be in proportion. So if the sides are in proportion, then the angles will be also equal. So which we know that. So this is what called side, side, side theorem. Let's see the last one, which is side, angle, side. So same, we can say if one angle of a triangle is equal to one angle of the other triangle. Now we have given like triangle ABC. Let's see ABC and triangle ABC and triangle X, Y, Z. So here we have given that A and X are equal. If angle A is equals to angle X, if angle A is equals to angle X, and if the two sides, which is the corresponding sides which includes this angle, we need to take AB and XY and AC and sorry, this needs to be AB and XY and it needs to be AC and XZ. Let me change that. It will be AC and XZ. Yeah. So if angle A is equal to angle Z, then AB will be proportion to XY and AC will be in proportion to XZ. So if one angle of a triangle is equal to one angle of the other triangles, which is angle A equals to angle X, and the sides including these angles, we need to take only the sides which includes these angles are proportional, then the two triangles are similar. So if that's the case, if AB by XY is in same proportion to AC by XZ, then we can say triangle ABC is similar to triangle XYZ. So there are three different criteria, which is first is angle, 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 then side, side, side and side, angle, side. So these are the criteria for where we can prove that two triangles are similar. Let's summarize the chapter now. Summary, the first we have mentioned, we have learned that basic proportionality theory, which says that in triangle ABC, if DE parallel to BC, if DE is parallel to BC, let's write here DE. It's a parallel line which is parallel to BC. Then AD by DB will be equals to AE by EC. So this is what said by as per basic proportionality theory. If triangle in triangle ABC, if DE is parallel to BC, then AD divided by AD by DB will be in proportion to AE by EC, which says that if a line, we can just see the definition which we have learned. So as per the basic proportionality theory, if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. Correct? So other two sides are divided in the same ratio. So now what is the second one is converse of basic proportionality theory. Just reverse of that. In triangle ABC, if AD by DB, we have already given AD. This is D and E. If AD by DB is equals to AE by EC, if they are in proportion, like AD by DB is in proportion to AE by EC, then DE, the parallel, the DE, the line drawn here will be parallel to BC. The DE will be parallel to BC. So as per the converse of basic proportionality theory, we have learned that if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third sides. Like if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. So that is basic proportionality theory and converse of basic proportionality theory. Now the second summary was like similarity of triangles. How can we say two triangles are similar? Like let's see two triangles ABC and XYZ. We can say both triangles are similar if the corresponding angles are equal. Like corresponding angles are A and X, B and Y, C and Z. If the corresponding angles are equal, also the second criteria is AB by XY, AB the corresponding sides AB by XY and BC by YZ and AC by XZ also should be in proportion. If these two criteria are satisfied, then we can say two triangles are similar. The first one is the corresponding angles should be equal and the corresponding sides of the two triangles should be in the same proportion. And finally, we have learned the criteria for similarity triangles. There are three different criteria. First one is angle, angle, angle or angle, angle. Both are same. Like as per the sum of a triangle, if we have that sum two angles are equal, then we know that the third angle will be also always equal. So as per angle, angle, angle theorem, if we can say angle A should be equals to angle X, the corresponding angles, angle B should be equals to angle Y and angle C should be equals to angle Z, then we can say AB is in proportion, AB divided by XY is in equals to BC by YZ. All the corresponding sides are in proportion. If the three angles of a triangle are equal, then we, as per the angle criteria, we can say the corresponding sides will be also in proportion. And the second one is side. As per this, if AB by XY, like if the corresponding sides are in proportion, if the corresponding sides of two triangles are in proportion, then their corresponding angles will be always equal. So this is just the reverse of the angle. As per angle, we are saying that if all the corresponding angles are equal, then the corresponding sides are in proportion. And in side we are telling that if all the corresponding sides are in proportion, then all the corresponding angles are equal. And the last one is side. In that we are telling if angle A and X, like one of the corresponding angle are equal and two sides including the corresponding angle, angles are in proportion, then also we can say that both triangles are similar. Like in this case, if A and X are, these two angles are equal, which is corresponding angles, and AB is proportion to XY and AC is proportion to XZ, then we can say triangle ABC is similar to triangle XYZ. So now we have completed the chapter explanation. From next video we will do the textbook exercises and also few more samples from other worksheets. If you are new to the channel, please don't forget to subscribe. Thank you for watching.